Assalamualaikum and hi. So in this video, we're going to look at 2.2 uniform accelerated motion under chapter 2. There are one learning objective in this subtopic. Learning objective 2.2a, derive and apply the equation of motion with uniform acceleration. As we can see, it is emphasized that we have to know how to derive and also to apply the equation. To start with, for uniform constant accelerated motion, the velocity changes at a uniform rate. As we are only going to look at a uniform acceleration cases throughout our syllabus here, the velocity is going to change at a uniform rate. So let's say we have a graph of velocity versus time graph, and we have our lines in the graph such as it started from a U and ends at a V, where from this graph we can deduce that U is the initial velocity. This is the initial velocity, and also V here is the final velocity. Okay, when t is equals to 0, when our t here is equals to 0, our object is already in the motion with a velocity of u. So when t is equals to 0, our velocity here, initial velocity here is already, our velocity here already has a value of u here. And then after a certain time, t is equals to t, our object has reached a final velocity of a v. When t is equals to t, our velocity now becomes final velocity v. So there are a few information that we can gather out from the graph. As we have looked in our previous subtopic, for the graph of velocity versus time, we can take out three information. The first information is the velocity itself, which means we can know what is the velocity at a particular time. For an example, at t is equals to 0, our velocity is equals to u. And then let's say at t is equals to 2 seconds, we can also know what is the velocity by reading it from the graph here. And then the second information we can gather is the acceleration, where the gradient of graph velocity versus times will give us the gradient. We have also looked at this in our previous subtopic. This is the gradient of the graph, and this gradient here represent the acceleration. And the final information we can gather is the displacement. Displacement comes from the area under the graph. So this is the area under the graph, and this whole area here is our displacement. Now, we are going to use all this information that we can gather out from the graph to come up with equations of the kinematics here. So let us first look at the information based on the gradient of the v versus t graph, where the gradient here, as we know, refers to the acceleration. Okay, according to this gradient here, we have our m here is equals to y2 minus y1 over x2 minus x1, and the gradient now is equals to acceleration. Let's say I'm going to choose these 2 points here, this one and this points here. So I will be having a coordinate of t comma v and also 0 comma u. These are my coordinates, so I can simply substitute in. My y2 would be v, my y1 would be u, and my x2 is my t, and my x1 is 0. Therefore, I'll end up with an equation of a is equals to v minus u over t. So this is the equation of the gradient from the graph of v versus t. By rearranging this equation, I will get an equation such as v is equals to u plus at. Alright, so this is our first equation for the kinematic linear motion. V is equals to u plus at. And then next, we're going to come up with an equation based on the second information here, which is from the area under the graph. The area under this particular graph, the area here represent the displacement. So as we can see, we have the area of the trapezium. Area of the trapezium here, this would be the area. Let me highlight the area here. So we know the trapezium has an area of 1 over 2, A, B and C here. We have A plus B multiplied with C. And then we're going to use this equation to substitute according to the term in our graph here. So our displacement here would be S is equals to 1 over 2. U is our A here, this length, plus V, which is our length on this side, which is the B of the trapezium, and also multiply with T, which is the length of this side, which is our C from the trapezium. So we'll have an equation of S is equals to 1 over 2 U plus V multiplied with T. This is our second equation. So we have already find the first equation, V is equals to U plus AT based on the gradient. Second equation, S is equals to half U plus V multiplied with T, which is from the displacement of the graph. And then next, what are we going to do is, we are going to substitute the equation 1 that we have obtained here into the equation 2. So I'm going to rewrite the equation 2 as is equal to 1 over 2 U plus V multiplied with T. And then my equation 1 was V is equals to U plus AT. Now what I'm going to do is, I'm going to substitute my V from equation 1 into V from equation 2. So I will end up with S is equals to 1 over 2 U plus, at the place of V, you're going to substitute U plus AT multiply with T. Therefore, simplify your equation, you will get something like S is equals to UT plus half AT square. This is your third equation for kinematics of linear motion. Alright, I'm going to just rewrite the first three equations. V is equals to U plus AT. We obtain this based on the gradient of the graph of V versus T. And then we have the next equation, S is equals to half U plus V multiplied with T, which we got from the area of the graph. And then next we have S is equals to UT plus half AT square, which is the combination of equation 1 and also equation 2. And then now we're going to look at the last and final equation that we can use for the kinematic of linear motion. We're going to start from equation 1. We take the equation 1, V is equals to U plus AT. We rearrange such as making T as a subject. T is equals to V minus U over A. And then we are going to substitute this into our equation 2. Alright, so I'm going to rewrite my equation 2. Equation 2 was 1 over 2 U plus V multiplied with T. After rearranging this equation, making T as a subject, I'm going to substitute equation for T into the equation 2 here. U plus V multiply with T, we are going to substitute V minus U over A. And then you do your max, you simplify the equation, you will end up with V square is equals to U square plus 2 AS. This is our last and final equation for kinematic of linear motion. V square equals to U square plus 2 AS. Alright. Okay, so the term that we have used here is S for displacement, V final velocity, U initial velocity, A acceleration, and T is the time. We are aware of all these terms because we have used this throughout. So all these terms, S, U, V, and A are vector quantities. The direction of this quantity should be taken into account during the substitution for kinematics equation. Okay, so I'm just going to rewrite the four equation. The first one is V is equals to U plus AT from the gradient. S is equals to half U plus V multiplied with T from the displacement area under the graph. From the area under the graph. And then we have the third equation. S is equals to UT plus half AT square, which was the combination of equation 1 and equation 2. We substitute into the term V. And then we have V square is equals to U square plus 2AS, which is also combination of equation 1 and 2, where we substitute the term T into the equation. Okay, so these are the equation. We have to understand how to derive them. Maksudnya this whole process you should know the derivation from this gradient, area under the graph, substituting into equation 1, equation 2, and so on. You must know how to derive to come up with all these 4 equations. Next, you're going to apply them into the question. So before we apply, there are implicit data in problem. A few things that you have to take note, such as if you encounter the term initially at rest, okay, if you encounter this sentence in your question, initially at rest, which means your initial velocity is equals to 0, u is equals to 0, alright? And then if they say decelerates or brake, if they say the object decelerate, which means our acceleration is undergoing a negative acceleration, which is decelerating at this particular point. Or when the question mentioned the object brake, the car brakes and what so not, kan? Which means our acceleration is going to have a negative acceleration. And then let's say if in the question they said that the object started initially at rest and then after a certain minutes it brakes and finally come to a stop. So bila dia cakap finally stop, it gives an information that v is equals to 0. Uniform velocity indicates acceleration is equals to 0. Uniform velocity here is equals to constant velocity. When your velocity does not change, your acceleration is equals to 0. So these are the terms that we have to take note. Alright, let us look at example 9. You have a plane on a runway, takes 16.2 seconds over a distance of 1,200 meter to take off from rest. Assuming constant acceleration during takeoff, calculate the acceleration during takeoff and also the speed on leaving the ground. Okay, the first thing here is we are going to understand. The question here is about a plane. Alright, so let's say this is your plane and the plane is on the runway, and we know that before the plane take off, before it fly, it has to move along the runway and then only it can take off, it can fly. So your plane has to travel across the runway before it can take off. Okay, I don't know why my plane looks like a dolphin, but this is the plane. So your plane has to go across the runway before it take off here. Alright, so this runway is okay, so this is the situation in the question. So now we are going to take out the information. The question states that a plane on a runway takes 16.2 seconds over a distance of 120 meter to take off from rest. So we actually have 3 information here. The first one is the journey of the runway for the plane to travel across the runway here. It takes 16.2 seconds. Okay, which is the time taken here. And then the next information is the length of the the length of the railway, which is the displacement of the plane, s is equals to 1200 meter. So this is our displacement. Next information we have here is, it states that a plane on a runway takes 16.2 seconds over a distance of 1200 meter to take off from rest. So initially our plane started from rest, so the u here is equals to 0. So as you can see, you have the information of u is equals to 0, s is equals to 1200 meter, and also you have t is equals to 16.2 seconds. The first question here is to find the acceleration during takeoff, which means you want to know what is the acceleration at this particular point. Alright, so you're looking for A here. And then the next question is, what is the speed on leaving the ground, which is the speed here before it leaves the ground, before it starts to fly. You want to know the velocity here. So we have 2 questions here. Alright, looking at the first question, the acceleration during takeoff. So the acceleration at this particular point before it takes off is actually the same as the acceleration throughout it travels across the runway, because this is constant acceleration. The question states that it is having a constant acceleration. So acceleration dia akan samalah sepanjang perjalanan ni. And also our syllabus is on uniform accelerated motion. So the acceleration is uniform here. Alright. So we have 3 information. We are looking for A here, acceleration. First, let us rewrite all the equation that we have learned. The first one is V is equals to U plus AT. This is the first equation. Second equation is S is equals to U plus V over 2 multiply with U plus V over 2 multiply with T. And then the third equation is S is equals to UT plus half AT square. And then the fourth equation, ngam-ngam ada aeroplane tengah lalu dekat rumah saya ni. Equation 4 is V square is equals to U square plus 2 AS. So we have 4 equation here. Before we want to identify what we are looking for, we have to first choose the right. So before we find the acceleration, we need to know which equation. We have to choose the right equation for us to use. So for that, identify the equation that has unknown kita. Kita tengok dalam soalan tu, soalan nak cari A, so kita tengok equation mana yang ada A, because you need to find that. So the first equation has A, the third equation has A, and the fourth equation has A. Yang kedua ni tak ada, so kita akan buangkan dia daripada our option here. And the next, we're going to look at the information we have. You have U, S and T only. So you can either use the equation that involve these three terms sahajalah. Kalau dia ada term lain selain daripada itu, you cannot use because you do not have enough information. For an example, look at equation 1. Kita ada V plus U plus AT. Okay, V kita tak ada. That is the second question actually. U kita ada, T kita ada. You are looking for A. Betul tak? You do not have enough information. You don't know your V, maka kita tak boleh guna equation ini. Next, look at the third equation. S ada diberi dalam soalan, U ada diberi dalam soalan, T ada diberi dalam soalan, A ada diberi dalam soalan. A is what you are looking for and T is also given in the question. So you can simply choose this equation. Kalau nak cross check equation keempat pun boleh. V tak ada, U ada, A kita nak cari, S ada. So ini pun tak cukup informasi, you cannot use. Alright, so we are going to choose the third equation here. The third equation states that S is equals to UT plus half AT square. So our S here is 1200 meter. U kita initially at rest 16.2 plus 1 over 2 acceleration. T square is 16.2 second. And then what you do is you're going to press your calculator. So we'll get our acceleration such as 9.14 meter per second square. And then next, the question asks to find the speed. Betul tak V? Kalau kamu tengok, A kita dah ada 9.14 ms negative 2. And then according to all this equation, kita ada 5 term iaitu U, V, S, A, T. And then based on the information from the question, U ada, S ada, T ada, A kita dah cari, tinggal V sahaja as an unknown. So you can actually use any of this equation lah. Yang penting mana-mana equation yang kita nak pilih ni kena ada term V, because that is what you're looking for. So based on the equation we have here, equation 1 boleh guna sebab ada V, equation 2 boleh guna sebab ada V, equation 3 tak boleh guna, equation 4 boleh guna. And then you choose lah, sebab semua term sekarang kita dah ada, U ada, A ada, T ada, semua ada. You can choose apa je yang kamu nak. So let's say kita pilih equation yang pertama lah, V is equals to U plus AT. U kita kosong, A adalah U kita kosong, U kita kosong, and then A is 9.14 multiply with 16.2. And then tekan calculator. Kamu akan dapat 148.07 ms negative 1. Alright, ini adalah jawapan yang kita dapat. It's okay, dia lari by decimal places dekat sini, tak ada masalah. Mungkin jawapan ini dia guna equation yang lain. Let's say we want to use the fourth equation. Contoh, V square equals to U square plus 2AS. Tak ada masalah. Boleh juga guna. V square is what you're looking for. U square adalah 0 plus 2. A is equals to 9.14. And then S kita adalah 1200. And then you press your calculator. Kita akan dapat V sebanyak 148.108 which is 11 ms negative 1. So this one you get exactly the same macam given dekat sini. Ini pun betul. Yang penting angka dekat depan ni tak larilah 148. The decimal places lari sikit tak ada masalah. This is because we are using different equation. We substitute in different term. Okay, decimal places lah sebenarnya itu je. Alright, both answer is accepted.